As I've said before, the universal k method is basically universal. Let's see if we can use the universal k-value method to solve this problem. Let's take a look. Given that x to the fifth power plus x plus 1 equals 0, find the value of x cubed minus x squared. Everyone, when you see a quintic equation in one variable, can you solve it? No, you can't. Quintic equations in one variable are very hard to solve. If we can't solve it, what should we do? Let's try using the universal k-value method and see if it works. Let's just assume it's equal to k, okay? We're dealing with this big chunk, x cubed minus x squared. Let's just assume it's equal to k. Wouldn't it work if we just figure out what k equals, right? Let's try calculating it. If x cubed minus x squared equals k, then can't I get what x cubed equals? It equals k plus x squared, right? Is there any problem with that? Everyone, I just moved x squared to the other side, right? Okay, now let's raise the power again. Isn't this to the fifth power? How do we raise the power again? Multiply both sides by x. The left side becomes x to the fourth power, and the right side is kx plus x cubed. Right? Is there any problem? If we raise the power again, what does x to the fifth power equal? It equals kx squared plus x to the fourth power, right? I multiply both sides by x. Okay, now I know x to the fifth power equals that. Then can I reduce the degree in the original equation? So that's how it works. That means I can replace x to the fifth power with this expression, right? So what does the original equation become? Kx squared plus x to the fourth power, which means x to the fourth power plus k times x cubed plus kx squared. So kx, right? Then add x plus 1 and then add x plus 1 again equals 0. So the original equation becomes like this, doesn't it? Then let's reduce the power to 4. What is x to the fourth power equal to? It's equal to x cubed plus kx, right? I'll reduce the power again. Fourth power becomes third power. See, it's x cubed plus kx. Add k, and this part is just copied down from before. Kx squared plus x plus 1 equals 0, no problem. When doing challenges like this, everyone make sure not to copy it wrong. What is x cubed equal to? Isn't it equal to x squared plus k? Reduce the power again, so it's x squared plus k. Then bring down the rest. Plus kx squared plus x plus 1 equals 0. All right, so has it turned into this form now? Is there any problem? Can we reduce the power any further? We can't, right? X squared can't be reduced anymore, can it? If it can't be reduced, what do? We combine like terms. This kx squared, and here's another x squared. Combine like terms, so it becomes open parenthesis k plus 1 close parenthesis x squared, right? Any questions? Combine these two. K plus 1 x squared, and this kx and x can also be combined, right? K plus 1 times x, combine those, and this is the constant term. The constant term is k plus 1 plus k plus 1, which equals 0. Did it turn into this form originally? What do we do at this step? The next step. Factor out k plus 1. Everyone, factor out k plus 1. After factoring out k plus 1, what does the original become? X squared plus x plus 1 equals 0. Right? Hasn't the original expression turned into this form? Okay, some students have noticed it, some students have observed it. Isn't it true that this equation definitely can't be equal to 0? Why can't it be 0? Because its discriminant is less than 0. B squared minus 4ac is less than 0. In other words, this equation opens upwards and has no solution. If a function opens upwards and has no solution, that means it's always greater than 0. It's always greater than 0, so it can't possibly be 0. That means only this part can be 0, right? Right? If you want this equation to hold, isn't the only way for it to be true that this part equals 0? So doesn't that mean k equals -1? If k equals -1, then this value is just -1, isn't it? If you don't believe it, you can verify it using other methods to see if the review is correct, everyone.